In this clip, we're going to talk about the normal curve and the area under the normal curve. And we'll kind of set up for the more complex examples we'll do in the next video. So last time we talked about the standard normal distribution. The important thing to remember is that when we standardize a variable, the mean is always 0, and the variance or standard deviation, excuse me, is always 1. And this is, again, by definition. That's why we translate it to the standard normal distribution, is so we have mean of 0, standard deviation 1, so it's simple to work with. And z-scores are basically, you can think of them as the standard deviation units, how far each observation is in terms of the standard deviation from the mean. So this shows the area under the portions of the standard normal distribution, this curve right here. So between -1 and 1 standard deviation, so from down here, 1 standard deviation below the mean to 1 standard deviation above the mean, is about 68% of the area. So 68% of observations are going to fall into this area under the normal distribution. Now, there's a probability of just over 95% that a value would fall between plus or minus 2 standard deviations. So we go out here, 2 standard deviations below the mean, 2 standard deviations above the mean. This whole area right here is filled with just over 95% of the values. And now if you go out to 3 standard deviations here, and then -3 standard deviations down here, all of the yellow areas under the curve, there's more than a 99% chance that a value is going to fall between those, the plus and -3 standard deviations from the mean. Almost all observations are going to fall within that area. Now, if you work in manufacturing or heavy industry, you may have heard of Six Sigma. Six Sigma seeks to reduce defects to like a number of 3.4 defects per million opportunities. Now, the sigma they use here is referring to the standard deviation, and they're working with the normal distribution. That level of 3.4 defects per million is the level of 6 standard deviations above the mean. So what they're trying to say is the errors are extremely, extremely rare. We have over 99% of the data falling within 3 standard deviations. We're talking about way out here at 6 standard deviations away. So the center line here represents the mean, but in the normal distribution, it also represents the median and the mode. So the most common value is going to be the mean, and also the middlemost value is going to be equal to the mean. So all three, mean, median, and mode, are equal. So at this point, the z-score in the standard normal distribution is 0. Half of the observations are going to be above, so on this side all the way out to infinity, and half the observations are going to be on this side of the mean, running all the way down to infinity.